Okay.
How do we get rid of the things up here?
Now is it fine?
Can you put your talk into full screen mode?
Full screen.
Full
Okay.
screen?
Yeah. Okay, let me see. Yeah. So now it's fine. It is fine?
That's better. Just give us 1 second. We're just,
Yeah. Yeah, sure.
oh, that's great. Thank you. Okay, we're great.
Okay.
Uh, so let me just introduce you. This is Payel Sadhukhan from the Neotia University. And you'll be talking about exploring the transferability of cancer prediction models across races. So thank you very much. Go ahead.
Yeah. Yeah. So my background is I have a PhD in machine learning and my research focuses on the machine learning area only. So we have some applications of machine learning in cancer prediction. I mean, not I haven't done any work so far on this area, but there are people doing this. So I will go into deep regarding our not I won't say it's a research, but it is a research proposal, more of it. So we all know about cancer. It is a cause of concern because it is like a death pill. Whenever we hear that someone has cancer, we know that most of the time the thing that comes to our mind is his or her days are limited. There is fear, the near and dear ones fear about the topsy turvy in their lives and so on. So it is a fundamental cause of concern and fear among the masses. Uh, the factors that contribute to cancer prevalence and prognosis, there are several things like lifestyle, surrounding environment. Like it is said that people who reside in air polluted region, they have a tendency to develop lung cancer and such things. Lifestyle, like sometimes they say that sugar intake is related to cancer prevalence. I don't know if it is true. So, and there are several uncontrollable aspects like genes. They say that we inherit the cancer traits from our forefathers and foremothers. And so, with related to genes is races. And and there is certain role of races or the genes in cancer prevalence and prognosis. I got this resource from the net. It shows that the African American men, they contracted cancer most during 2003 2007, and the Asian or Pacific Islanders, they were the least. So it is with respect to US population. So we can see that the cancer prevalence is not uniform among the races, and this particular data is related to like all types of cancer. And if we take specific cancers like lung cancer or skin cancer, breast cancer, so the prevalence tends to vary across the races. So I mean, race is a factor to study the what to say the difference in prevalence of the disease. So quite a few machine learning research has focused on the study of cancer. So it is more on the prediction side, like someone has learned the features related to cancer. It can be the genes and all, and they want to predict whether if the person has cancer, how long he or she can survive. Or if the data set is on mixed type, like there are some people with cancer and some people without it, the task is to predict who can have the cancer and who will not have the cancer. So there are research in this area. And thinking on the same line but a slightly different track, there is our proposal that we want to investigate the transferability of cancer-focused machine learning models. What I would like to explain, it is like, suppose we get the data set of cancer prevalence. Let us consider the lung cancer data of white people, white Caucasian. We build a machine learning model for predicting cancer among the masses. Like here we assume that the data set has healthy as well as afflicted people. Only but they are only white. So we train the model using white data set. So our question is, now if we want to use this model to predict cancer among the Black Americans, will it work good? So this is one thing we want to explore. So in machine learning, there is a thing that the training and the test data has to have a similar profile. If the training data and the test data varies, we can expect the model to fail. So our primary goal is that thing. So the training data will originate from one race and test data will originate from another race. And we will consider the same type of disease. Like if we consider lung cancer as the training data, so we will predict only lung cancer for the test data. But the race has to be different, and we want to see if we get a difference in result, whether the not the accuracy, I mean accuracy can be there can be precision, recall and everything, whether the performance falls when we use the model to predict a different race. So that is the goal of this research. So as I was saying, that ML models show a certain extent of data bias. So when we train our model on race X, so that data gets our model is biased to the features, nuances of race X. So we want to know whether it will work good on race Y. And if we expect that the performance will not be as good, then we want to look for ways to make that model efficient to predict race Y. So one thing we have in mind, class imbalance is a serious issue when we are building models. So if the imbalance of the cancer prevalence varies between race X and race Y, we can expect a fall in performance. And more so, if if race Y, which is the test race, if its imbalance is more than the race X, then we can certainly expect that the results will be bad. So we want to address that. So this is the goal of my research. I mean, I should say, I'm writing the codes, and since I have a certain bit of intuition, now I have to look through the code if my intuition is correct. So the work is in this stage. And that's all. Thank you. I should like to answer any question if there is. So thank you.